Okay.
Hi, Stuart.
Hi, Chandan, and hello, everyone. Welcome to our expert webinar, Data Lakes and Their Impact on Digital Transformation and Analytics. Our guest today is Chandan Vijay, who is the Senior Director of Products at Cognizant. Before we start, I'd like to share controls of the WebEx platform. Probably everybody's been to a WebEx seminar by now, but when you want to ask questions, we will handle those in the Q&A section at the end of the presentation. So please put those in the Q&A box. Address them to all panelists, and we will log those and present as many as we can to Chandan as the time permits at the end of the session. You can also put in chat messages if you wish. They are not visible to other participants, just to us on the panel. Be sure to address them to all panelists so that we do see them. And with that, I'm going to do a poll, which is one of the features we're going to be doing a couple of times here. And the first poll is, how much experience do you have and how are you feeling today? That second question is something we like to ask since this pandemic situation began. Make sure people are feeling okay, working from home and in isolation. So give you about another 30 seconds to answer the poll. Just about another 10 seconds. Three, two, one. And see the poll result. The audience today is heavily weighted towards people with long years of experience. And I'm sorry, the poll question didn't quite match what's on the shared screen, but the other thing that's encouraging is that most of you are doing well today. And for those who marked thumbs down, we hope that by the end of the session, you'll have gotten some great information and be feeling a little bit clearer. So with that, I will introduce Chandan, and we will let him take the reins after the introduction. He is the Senior Director of Products at Cognizant. He is an outcome-driven digital technology leader in data and analytics with over 20 years of experience in the technology industry. About 17 of that was at General Electric, various divisions of GE in positions of increasing authority. And he is an expert in this field. And so if you'll bear with us, we will let him continue the sharing. Good morning and good evening, Chandan.
Sure, Stuart. Let me just quickly share the screen and I can take over the presentation.
There you go.
Let me know if everybody can see the screen.
Yeah.
All right.
Yes, we.
Great. Stuart, do you want to give this poll, or do you want me to start on this one, on the topic first?
I will start with this poll for the reason that I'd like you to be introduced to the audience and see how familiar they are with your topic.
Sure, certainly.
Let's do this one quickly. And again, about 40 seconds. We had a lot of people very interested in the subject of data lakes. So the question is, how well are people familiar with it? I think pretty much everybody has given their answers. So
Okay.
I'd say most people are answering that they've heard of them.
Got it. All right, so let me move forward with the presentation. And I'll quickly come to the introduction of data lakes. Now, as the poll suggested, a broad group of people is not very well aware of what data lakes are or how they have been in use in the industry. And what exactly is a data lake? Data lake is typically a data repository. It hosts large, if I were to call like enormously huge, large quantity of data, amount of data hosted in an environment, preferably leveraging cloud technology and using big data technologies, which is like Hadoop, HDFS, Presto, Spark, Scala, and so on and so forth. The data lake also hosts a variety of data, which is like it can be structured data, semi-structured data, unstructured data, which could be your file systems, and so on and so forth. The applicability of or the application's usage of a data lake vary from the analytical tools to building dashboards, reporting solutions, serving as a data store, which is like if you want to provide data as a service from a single stream, you can serve that as for that also. It is immensely used in data science, AI, and ML services. So data lake, in summary, huge collection of data in a single instance or a repository. I'll move on to the next one, which is a poll. Let's move on to a quick roll so that it gives me a bit of insights.
And what we're going to ask is what your current job role is, and that will help Chandan address the information to your needs. We recognize that some people may not work specifically in data science.
Absolutely.
Maybe they manage it, or they're an executive, or if you're a student.
I think it's going to give me a good insight to basically talk more on the areas where people are in the current roles and if they have an inclination towards moving into a different role.
3, 2, 1.
Okay,
Sorry about that.
no worries.
There we go.
Okay. So we have got 10% executives, program managers, project managers, students, and others. All right, broadly. Good. So this gives me a little insight about what do I need to specifically focus more. So as I said, right, how do you look at data lake? Now, I'm getting a couple of questions pinged across screen. So how do you differentiate data lake from a traditional database or data warehouses or data marts? Now, I think broadly looking at it, a couple of things which would come into picture is data processing. In a data lake, you typically store data which is unprocessed data. Now, I will come to later slides which will explain why I'm saying this, because data lake primarily is a repository. So any data that you're basically retrieving, it is stored at the very first instance in an unprocessed way. Whereas traditional data marts, data warehouses, databases have processed data, which is like you will have your tables, you will have schemas, you will have your joins, normalized data, structures, conditions, primary key, foreign keys, all associated with that. Whereas in a data lake, when the data comes in, it is in their raw format. It is exactly how it is from where it is coming from the source system. You don't change the data in the very first instance. It is stored as is into a data lake. Now, we talked about the variety of data which is in a data lake. You can have any kind of a data in a data lake, which can be your file data. You can have engineering drawings. You can have simple text files, your Twitter feeds, your Facebook feeds, simple, even transactions which are coming in from the point of sale registers, any kind of data which can go into a file system is kind of put up into a data lake. Whereas a data warehouse or a database will have a structured data. You again will create a schema. You will have your tables. You will have joins. You will basically organize the data in a form which can be basically passed to a query. In a data lake, your data granularity is at the lowest level. The transaction which happens, the data is passed on as is. You don't transact basically that data into a summary level or aggregated view, which is needed for your reporting views in a data warehouse. Any transaction, for example, in a general ledger or a point of sale or a Twitter feed, anything or everything which is there, it just comes in as is and is stored in a data lake in the exact form as it originated from the source. So you are having a data granular at the lowest level to which you can actually summarize when you roll it up. When you talk about latency in a data lake, traditionally data lakes are built for storing data and combining data into a single entity. Therefore, data latency typically looked upon is a very low one. By data latency, what I mean is the moment the data is created at the source, the soonest you want it to be in the lake available. So for example, you are at a point of sale, as I mentioned as example, you're selling an iPhone. The moment the transaction is completed, it goes into a database. At the same time, within a few seconds, that same transaction is replicated into a data lake in the totality as how it has gone into a source. So your customer details, your transaction value, your item that you've purchased, all of that goes into the data lake. Whereas in a traditional data warehouse or a data mart, you would traditionally be getting a data at a set period of time, maybe every 6 hours, maybe once a day, once all the transactions are completed. If you talk about financial data, once all the books have closed for the day, you would basically aggregate all of that transactions, you would basically pass on into your data warehouse. So lake, the latency is traditionally very low. You can get almost up to a real-time data also in the lake, whereas on a data warehouse side or a traditional database side, uh, it's at a certain volume level, which is like it may be coming in a certain period. Now the applications of traditional data warehouse is traditional reporting. You will create a dashboard. You will have certain metrics which are based on the data which is in the data warehouse, and you will be rolling up those numbers to showing it up. Whereas the applications usage of our data lake expand from, as I mentioned, it can be used in big data analytics, real-time data analytics. It can be used in a lot of data science applications. A perfect example that can come across in a very simple format is if you go to Flipkart or Amazon or any other traditional basically websites where you do your selling, the moment you select a product in Amazon, Amazon gives you a recommendation as to what other customers have traditionally brought along with that item. Now that is an example of basically data science and artificial intelligence built into their systems, which the moment you're opening up a page, click the link, it's working in background to look at the data for that product, who all have brought that product, what other products have they brought it with, and that gives you a recommendation. So in a sense, there is a large variety of applications that can be used using a traditional data lake versus a traditional database or a data warehouse, which contains data at a summary level or an aggregated level. I'll move on to the key elements of a data lake. Now, typically when you look at a data warehouse or a database, There is security which is built into it. There is a transactional which comes into a database or a data warehouse. You basically try to match like an aggregated data of volume data which goes into a data warehouse. Whereas the moment you talk about data lakes, right, it encompasses several large functions which are integral for making data lake a success. The paramount is security, data governance, because when you're having data at rest in a single location, now you can imagine, let's say an enterprise is there and they've created an enterprise data lake. They're having all of their financial information in there, all of supply chain, all of inventory related information, basically the entire company's data into a single repository. Imagine if that entity or that object or that data lake is breached, or if there is a ransomware attack which happens, you have a big problem on your hand because you've exposed all of your data which is addressed to the hackers or to the ransomware people. Data quality is paramount because in a data lake, whatever data you're getting, it is being used for analytical purposes, it is used for reporting, it is used for distribution, it is used as a data repository. So your data quality needs to be very important. Data discovery, which is like what is your catalog, what is your metadata for that objects that are being stored, that's again very important, because if you want somebody to use your data lake, they need to be able to understand what data is in there and how is that data interconnected with each other. In a traditional database, you only have your basically your primary key, foreign key relationship diagrams, which are already there. Whereas in a data lake, your data is coming in as is. It doesn't have any relational objects to it. So your data discovery and basically modeling is very important. Auditing is another big aspect when you look at it. If you are getting a data on a very frequent basis from the source, you want to make sure that the data that's coming in is absolutely as same as what is in the source. So you'll have your functional audits, you'll have your technical audits. Like if I'm getting 10 rows from the source, I want to ensure at the data lake I've got 10 rows. If in those 10 rows, the sum of X column is 100, I want to ensure at the source and the data lake, the number matches. So data auditing is another big aspect. Similarly, storage, data lineage, exploration is all very different elements which make up a data lake. And of course, ingestion, which is one of the most critical aspects, because at the very beginning of a data lake is ingestion. You will identify your sources of data which you want to bring into the lake. Then you will have your data engineering and data modeling team work to create the data ingestion pipelines. And they will govern basically like what's the frequency of data that's getting pulled and then set up into the data lake. How are you basically setting it up as an ingestion layer versus if you were to call the replication or the mirror layer, then how does it go beyond the replication or the mirror layer, which is like from the source, it has come into the lake and it's exactly the same. For making the data available for applications, it has different paradigms. I'll talk more about it in the next couple of slides as to how the data is being made available to the consumers. I'll move on to the next one. Now, if you look at traditional data cycle in a life cycle in a data lake, right? The engineers or basically the architects would identify what are the data elements that they want to basically get into the lake. Now that could be you have your financials data, you have your supply chain, you have your logistics data, you have your traditional, it can be like HR, payroll, any kind of information that is an organization, you want to get into a data lake. Now, the examples I'm trying to give you is trying to create like an enterprise data lake. Data lakes can be very specific. It can be a supply chain related one. It can be a purely logistics. It can be purely financials. However, to make it more efficient, more effective, the more threaded data that you can bring into a data lake, the more better results you will get. And by threading, what I mean is how you can tie back your enterprise data from end to end. For example, you have an organization which is like a service-based industry, right? So you will be having a customer, you're selling a product, which can be your services. For example, a traditional IT company like Cognizant, you will have your bidding process, you'll be basically doing proposal for customers. So your customer is an entity, sales is another one. You bid for a project, you won the project is created. The next part is the resources aligned to it. So you have your resources data, you have your project data. Once a project is created, you have your work breakdown structures, you will have your immense number of activities that go into it. So here you have your project data, you've got your resources data, which is like the project managers, data engineers, data scientists, web developers, anybody who is there, their information is there. Once they're working on their deliverables, you're making your timesheets, where you're making your work plans, all that information is there. Once a project is completed, you pass on the deliverable to a customer, you basically get the revenue, and you recognize the revenue, you have your financial information there. So the end-to-end information, if you talk about an enterprise data warehouse, you have your end-to-end information from the very beginning of basically from a bid to a revenue recognition. That's what an enterprise cycle would look like. So you would understand what your sources are. The next step would be in the collect stage, basically you understood what your sources are, how do you want to get it. In the ingestion cycle, you would basically define how you want to get the data into a data lake. Now there are several tools you can use. You can have streaming data coming into it. You can have Informatica as another tool. A lot of people might have worked on to it. There are tools like Talent, which basically pull data. There are tools like Databricks, HBR, Golden Gate from Oracle. These are different replication tools that different organizations use to get data from different sources and ingest into whether it's a data warehouse or data lake. The next step is blending the data, which is by means is once you've got the data into a data lake, which is your mirror, you typically want to make the data available for usage. So you basically kind of blend the data from different sources to make it more meaningful. You transform the data. Now, the big difference between if you talk about traditional data warehouses and your traditional or a data lake, in the old world, if you look at previously, how the data warehouses used to work was you will have your ETL jobs where you will extract the data from the source, you will transform it, and you would load it. Whereas in a traditional, or if you want to call the advanced or the modern data lakes, it is ELT. You extract the data from the source, you load it into the system, which is your mirror, and then you come to transform the data. Now, the transformation is basically a layer which you are making it available to basically making it available to your analytic tools or your to customers. For example, you can make it available through a data store into a form where people can basically, like say, you have a data store application which can combine the data into a single report and present it to you by doing certain fact and then dimension entities. And then you publish the data also to different applications for your data as a service, or you can do a distribution via different data pipelines, data as a service, again, data as a store, and different mechanisms to basically publish to different applications which can consume your data. For example, several data science applications or the customers use data which is finally available for distribution. I'll move on to the next step. If you traditionally look at data lakes, the ETL was the traditional way. You would have your ETL jobs scheduled to run at certain frequencies. If there is a trigger from source, it would just go and run at that certain frequency, or you would be running your ETLs, if I were to call, at let's say an hour or 2 hours or 6 hours or a daily or a weekly jobs. In a data lake environment, your data processing traditionally happens in two ways. One is batch processing, and then the second is real-time data streaming. Now, in a batch processing, let's say you are having a point of sale, you're waiting for your day to close, and you're basically combining all of the data and then getting it back into the data lake, which can be, let's say, an hourly job, or it could be a day job once it's all closed. The transactions are finalized. In a banking industry, you would want to wait till the day end, for example, to make sure all of the data is completed. The bank is able to reconcile all of the transactions. Once they close their data, then you get it processed within the lake as a batch processing. You're getting it like, for example, a 3-hour job or a 2-hour job or once in a day. It could be a once a week also for certain transactions. It could be once a month, once a quarter, something like that. In other ways, you also will have stream processing, which is like the real-time data coming in at a very low latency. Imagine the same example of point of sale, the moment exactly that the transaction has happened, you're able to send that transaction into the data lake also. And you're able to make a historical information processing also, that even though the data is not finalized, you are still marking it as a data, which is like, okay, this is transaction in process. You still are storing in a data lake so that you understand what the historical value of a certain transaction which happens. Or for example, a general ledger in an organization, the moment an entry is passed into a general ledger, you're moving that same entry into the data lake. Or the moment item is received in the data warehouse, the value is created in the data system database. The same value is replicated from the transactional database into the data lake. And then all of the transaction happens in a stream way. So that it's basically that the moment the transaction is happening, the data is flowing through the pipeline and getting into the data lake. That's why it's called as stream processing, because it's a continuous stream of data which is coming through. Another example could be your Twitter feeds. You're getting your Facebook data coming into a data lake because you want to process what kind of feeds or values are coming in. If you were to consider another example for stream processing, is like traditionally when the cricket match is happening, a lot of people are posting streams or basically tweets or Facebook entries while they're doing certain activities. The same feeds are basically processed by several organizations, hosted into their data lakes, and then done a real-time processing to understand what is the engagement of their customers or their potential customers on their products. I'll move on to the next one, which is morely broad talk about digital transformation through the data lakes. Now, when we say digital transformation, it has a lot of basically definitions if you're to look at it. And if you look at this specific picture, it really talks about the digital transformation in the real world, because a lot of organizations believe digital transformation is basically converting your applications digital. So you had an Excel-based system, you basically automated it through a web-based application, and that is digital transformation. To a certain extent, people may want to say yes. I would slightly disagree or actually broadly disagree on this one, because digital transformation is basically how do you look at your entire business and transform the business in such a way that through usage of digitization and digital tools, you can have more newer offerings for your customers. You can have newer work streams for your internal customers, for your external customers. How do you make more revenue? How do you make more profits? But not just by digitizing tools or applications, but how do you change the way an organization is worked? And that is where I think data lakes are a very integral part of bringing in digital transformations. Now, if you look at the consumers of a modern data lakes, it can range from an executive to a marketing operations to product managers to your traditional operations analyst, IT functions, business users, product support organizations, and everyone. Now, how do you look at these different consumers in a digital transformation way? For example, a data architect may want to look at the data lake in a way that, okay, how do I thread the data in such a way in the lake? Because now the lake has the enterprise data in it. The data architect wants to modernize the offering for his data products. Product manager working with data architect decides to say, okay, I want to make a new sales dashboard which gives me real-time insights about how the sales are happening, what are my key products which are happening, and how I can make the visualization for my executives in a more effective way. Now, when we talk about data architect and product managers, they're looking at, okay, how do I make the IT products such more versatile that I can make it more beneficial? Data architect would start looking at the different elements that are in the data lake and start to thread data as to, okay, how do I start looking at my end-to-end business process and connect the threads. Now, most of you are working in organizations, and I'm pretty sure most of the people would understand and agree that not a single enterprise runs on one single platform. Most of the businesses, most of the companies, most of the organizations have, let's say, one of their processes, for example, let's say their purchase or procurement process in a different system. Whereas when the product is received, when the purchase order was raised, it was run through a different system. When they actually received a product against it, they would receive it in a different system. The product is received, the payment is done through a different system. Now, if you look at all of these disparate systems, they are all different applications or different tools which are there. They don't have a clear linkage between them. When a product manager and data architect decide, no, we want to give an end-to-end view of my enterprise process, that is where you start threading your data and saying, okay, now I want to create my business process, and whatever data I have and data lineage I have in the data lake, I want to build a model on top of it, which is the mirror layer where I'm getting the data. I want to bring an analytical layer where I would basically architect my data and model my data in such a way that now I'm able to basically create a meaningful end-to-end flow of the data and get different reporting needs using that. So for example, you had data coming into it through ingestions. You brought it into a layer. Hypothetically, let's call it as a mirror layer, which is like you're getting it from different systems. You've mirrored it into your data lake. Now, if you want to make that data more basically usable for your consumers, for your analytic needs, for different people. So you're modeling the data and you're bringing it into a layer. Let's say it's your, if it's called, let's say, presentation layer, or maybe let's say analytical layer, because now your data is in a certain denormalized form where I can still join them and make them more usable. Through that layer, the product manager builds a product, which is, let's say, I want to make a data store where people can come and get the entire sales data because they want to do run their own analytic in their own application. So they're able to get that data through that product. Similarly, through the same product, the product manager says, I want to be making my financials data from the lake to the finance community, so that if they want to substantiate the data for their executives, if they're asking them for a certain data, I'm able to give them from the same lake. Now the lake is actually working as a single source of truth for them. For the enterprise now, the lake is working as a single source of truth. The product managers, the data architects, they're all working in conjunction to make that analytical layer more meaningful for the analysts, for the business users. Now, a lot of practicality of a data lake comes in when the data lake is made available through the self-service analytics or self-service data availability. You've got your data lake, you've got your analytical layer, you build tools on top of it, which can be used by your operations analyst, which can be used by, let's say, the marketing operations, the analysts, the business users, to build their own analytics, to build their own needs by threading the data together. Now, from the mirror, you made an analytical model and you brought in the lake. The difference, the challenge which comes into this is traditionally data lakes are meant for storing data. Therefore, when you want to build a system on top of a lake, you may want to call it as enterprise data warehouse, or if you want to use a data lake itself for creating an analytical model, you can do it. However, traditionally, lake has a slow, if you have to call the processing time from acquiring data, because a lot of tools that are there in big data, they're meant for ingesting the data at a very high volume, at a very high speed. Whereas if you bring in another system to parse the data and make it for analytical needs, that'll be better. So if you look at consumers in a data lake, that is how you start understanding how a data lake can actually help you transform the business in a more efficient way. You have your entire business data in a single location, an enterprise data. You have your experts which understand those different data elements. If you help build a data lineage and a data model and your analytical platform on top of it, and make it self-service and self-sustained, then you're making your business more enabled to go and look at it. Okay, if the sales team wants to look at the sales data in a more real-time way, you already are having a real-time data coming to the lake. Your analytical model needs to be refreshed at the same frequency, and you can make available the real-time metric to your executives, your different teams which are on ground. In traditional data warehouses, you had your frequency of batches where the data would get updated, the data would get processed, cleansed, and then transformed to make it available for the reporting needs. So you always had, if you were to call basically descriptive analytics, which is like, okay, what has already happened in past. I'll move on to the next one because that talks about what I'm talking right now. If you talk about analytics through your data lake, right? Now, the analytical models that can be worked through a modern data lakes is you can have your descriptive data analytics, which is like which is today available through a lot of traditional data analytical platforms, data warehousing platforms. Like, okay, something has happened in past. You're talking about descriptive. It has already happened in past. The transaction is already there. We're just simply bringing into a reporting platform and showing that this is what my revenue was till about a month back. This is what my travel spend was till X date. This is how it looked like. Now, if you look at the usage of data, which is coming in through a data lake in a real-time basis, you can also build through a diagnostic analytics, because now you have data spread across the different domains and different streams. You're not just having one single domain which is there. So you can try and triage as to what happened in the transaction. For example, you received a certain product for which you had the purchase order raised. The payment term was 90 days. However, the payment wasn't released till 120 days. Now, if you had disparate systems, you probably cannot triage why this happened. Whereas in a data lake, in a clearly defined model and a threaded data, you can understand which are the purchase orders which we have received but not paid, and then trying to triage the data through the receivables and through a banking system data, you can triage as to what happened. Why did it happen? The transaction failed, the banking transaction failed because the account number was incorrect of the customer. And then that is all of the triaging which can happen when you have a threaded data available through a data lake. In a traditional database or a data warehouse, you cannot accomplish this because, as I mentioned, if you have disparate systems, by bringing in data into another systems, you are customizing it, which is making it more difficult for your future upgrades of your original systems. And by that means, you're creating more complexity, creating more operational issues for your transactional systems. Now, coming into the next two parts, which is predictive and prescriptive, I think that is where the data lake comes into strong play. Because when we talk about data lakes, we talked about the large or the enormous volume of data that can come in. The second part is the data is real time coming in a broad sense. So in that way, the data science, the machine learning, the artificial intelligence comes into a play. Now, when you want to do the predictive or the prescriptive analytics, which is like in a predictive, which you understand like, okay, what happened when it happened, you're looking at data and you're trying to build a model. In a data science, in a machine learning model, you typically start building a model looking at historical data and trying to play with different parameters to come to a situation which is more like your closest to your real results. So you took a historical information of, let's say, last 10 years data through a data lake, and you're applying your machine learning model onto it, and you're trying to compare as to like, what is my real last 1 month results looking like? Is it really what was the result on those X months which I'm trying to build a model with? So you have your whole historical data, you built a model, and you compared with your real-time data in that model as to know those period, did the model completely or 95% match with the real results? And then you start applying that model into your fresh data and your upcoming real-time streams, and you start observing as to what is the efficiency of that model. So that is helping you, because that large amount of set of data actually helped build you a much finer and a much closer model to what your real world is. The next is basically the prescriptive analytics, which is like, okay, what happened, when happened. And then the third part is which a lot of broad, if you were to call analytical tool, don't give that capabilities. There are some uh, suppliers which do give a lot products wherein you can simulate data as to like, if I'm applying my data science, if I'm applying my machine learning model in this data, and if I'm getting this result out of which, if I change a certain variable into it, how does it impact my overall model and how does it impact my result? That is what you're simulating, and that is what you're doing a prescriptive analytics about. As to if I'm, for example, if you're getting real-time reservations data into your data lake, which is your, let's say your travel data, your organization is having, let's say 300,000 people in the company, travel spend is there. If you understand where the people are traveling, you can basically simulate if you reduce a certain X number of travel or for a certain business unit, if you say there's a travel freeze, how much of dollar savings it's going to give you. Now those kind of prescriptive analytics you can have through different tools and say, okay, if I'm applying these models, how much of benefits it's going to give me. Or if you talk about, for example, you have got your procurement, you have got your payment terms, by applying your data science, your machine learning models, and giving that, okay, these are the biggest suppliers which I have. And if I simulate that, if I change my payment terms from 90 to, let's say, 150 days, what's my impact going to be? Are these suppliers going to reduce basically selling me the products? Or if this customer, if I get them more discounts, will they come to me more? So there are different kind of prescriptive analytics you can actually start building through it. Now, both the two ends, as I mentioned, are more effective when you have the large volume of data available through a data lake. This is broadly I had in terms of basically presentations. Stuart, Arjun, I'll move to the questions and answers.
And we have
Stop sharing and let me give the control back to you.
All right. Now we're in the questions and answers, and we've got a number that came in from the audience. Here's an interesting one. If ERP from Santa, if ERP is doing the same kind of job, how is it differently? How is it basically different from data lake?
Absolutely. I think that's a pretty good question. Let's talk about Oracle ERP for a second, right? And I'll take an example of, for example, HR data. Now, traditionally in an ERP, you don't maintain a lot of historical information. For example, OHR is Oracle HR is a data set. When you have an employee joining in a company, you create a record for him. When the employee moves into a different role, when the roles keep on changing, to a certain extent, the different values are maintained to a certain extent, but not the entire historical information. Whereas each of the transaction changes that happens, while it is in if you have to call in the staging layers in a different database, you can pass it on to your data lake and still retain your historical information. So for example, a manager hierarchy in an organization, usually it is not maintained forever in an organization as to when you joined your company in the very first day, what was your hierarchy starting from you all the way to your CEO. Whereas after 3 years, what is the current hierarchy? Whereas in a data lake, what you're doing is you are basically copying transactions which are not changed, or basically like in a data lake, you're trying to see if the transaction is not changed, the data is not changed. I'm not replicating it. The moment it's reflecting a change, you're going to create a copy of it into a data lake. And you can say, okay, I want to maintain a historization of that data. Now, what it does is It gives you a complete history of how did it change. A traditional ERP stores a transaction. Once a GL is finalized, what different sub-ledger entities it went through, it traditionally would not maintain it. So you lose a certain flow of data in a ERP, in a transactional flow system, whereas the moment those changes are happening, where there is a small change happens, you can still replicate that data back into your data warehouse or a data lake and create a historical information of that and maintain it forever. So to a certain extent, historization is a big piece. Now, as I mentioned, right, ERPs are doing a certain amount of work. As I said, I haven't seen a single enterprise in the world, even Google runs multiple ERPs. It's world's finest, uh, basically, company in terms of the search engines, in terms of products. However, when they look at their enterprise, they still run multiple ERPs. So when you want to thread all of that information together, you want to make sure that how do you bring that data together, and how do you make it more worthwhile for your customers, for your internal users, for your enterprise. And I think that's where data lake differs a lot from ERP, because it's not just a transaction system. It's basically keeping your historization data as well as threading the data from different ERPs too.
That dovetails with another question about whether a data lake replicates an OLTP, an online transaction processing database. Basically,
it does in a certain extent, yes. It does in a certain extent, because the moment you want to make the data, uh, if you want to use the data, right, you cannot have partial data coming into your lake. As I said, the data which will come into the lake is at the most granular level, the lowest level of entity. So that if you're creating an ecosystem where you want to give your CEO a total roll-up of a number, and the CEO asks a question to his general manager, how did you arrive at this question? The general manager should be able to go to his senior manager and say, hey, give me a substantiation of how did you arrive to this one. They should be able to come to a data mart and say, okay, give me all the underlying transactions or the volume which is there to be able to prove that. So yes, it does replicate OLTP, and it will replicate at the lowest transaction level.
Ankit asks, is it secure to keep everything, all the data in a lake under the same cloud? Or are there regulatory issues with that or security issues with that?
So if I understand the question, you're talking about, is security concern if there are different data sets which are there in a data in a cloud? Is that my understanding correct?
I think that's about correct. When, especially the questioner asks, if data is consumer oriented, you fall under a number of different regulations about data security for consumer information. So
Absolutely. So if we remember, like my presentation talked about the different key elements of a data lake. Governance and security is as I said, was very paramount, because you may have the PII data, which is like personally identifiable data. Healthcare is a big industry where data lake is going to play a very critical role. Now, if we talk about healthcare as a domain, for example, right? How do you build up a great MRI machine? You build a great MRI machine because you run different machine learning algorithms on the different imaging data that you got from the different machines across the world. And you're applying your machine learning algorithms in it to say, okay, how do I identify if an anomaly that is shown in an MRI, which is like in a healthcare data, is actually a cancerous growth or not? Now, when you're doing that, basically all your imaging data is actually the PHI, which is public health data, which is, and it can be identified or it can be tagged to a person. Now, US has severe laws, and so does with European Union and several other countries. So yes, securing the data becomes paramount in a data lake, especially in a cloud. A lot of cloud native providers are assuring multiple level of security and regulatory compliance. And then you can basically work through your different organizations, different auditing organizations like KPMGs or the Big Fours to certify your data lake. For example, when I was with GE, uh, we worked towards certification of the finance data lake or SOX certification. Now, SOX compliance is one of the key regulations and compliance is requirement for financials data for any organization. And you can work through those different paradigms to get your data lake certified. Your cloud providers can help you basically ensure that there is a right level of security implemented in it. Now, since data in a data lake is sitting at rest, you may want to implement the cloud security, which is like, how do I encrypt data at rest? How do I make sure that there is right checks and balances in the data? How do I bring in the right authentication and authorization levels so the data is not available to everyone and anyone? I hope I answered the question.
Yeah, that sounds like a great answer to that question. On a related topic of reliability, Rushman asks if there are ways to protect against the vulnerability you mentioned about a data lake as a single point of failure.
Right. Look, when we talk about data lake as a single point of failure, yes, there is a risk in that. However, using cloud native technologies or using cloud technologies, I think you can build in replication capabilities. A lot of cloud providers provide more faster, basically turnaround times for their infrastructure needs. Having more scalable environments in your cloud, you can ensure that storage is, because storage is one of the paramount underlying foundations for any data lake, because you're having continuous coming in data. Your storage is the most important need. And a lot of us are aware we had a outage of Google services a couple of months back in aspect. I think it was in December sometime, where the entire services were not rendered available. Now it was because of a code change that went into their systems, which made the storage not available to the applications. So making sure that you have a scalable environment, you have the right, if you have to call the infrastructure set up for your scalable and reliability. When you have multiple nodes for your data and your basically replication nodes, you can ensure that your cloud hosted data lake is more reliable.
Thank you for that. We have just a few more questions, and there's a lot of questions we won't be able to get to, but we have I think a few more minutes for questions here. Piyush asks, does it make sense to create a data lake based on a subject area, or to logically segment a data lake based on different functions or subjects?
I think it all depends on the contextual needs of the data. If the business doesn't wants to basically look at their overall business process, but they want to focus on a certain specific area. For example, finance is a great area where you can have the complete financials data lake created. However, to make meaning of that data also, you may still want to bring in certain more domains so that the data can be tied back to a certain granularity. For example, if you want to tie back to your data, right? Your financials data can come from multiple sources. Now you want to make sure that your payables, your receivables, your banking systems data, they all tie back into that lake. So finance as a function becomes a data lake. You can look logistics as a data lake. You can look at supply chain as a data lake. However, you want to make sure that the relevant cross-reference data that you would want to have is also ingested into a data lake. So it's not entirely needed to have your entirely, if you were to call the enterprise data lake, but you can have a domain-specific data lake.
Makilla asks if there's value in pushing data coming from web analytics tools like Google Analytics into a data lake to build up your base of customer and behavioral data.
I'm not sure I quite got the question, Stuart. Can you repeat the question one more?
I think what she's asking is, would a data lake be useful in aggregating analytics, web analytics, like from Google Analytics, so that you can then analyze consumer and behavioral data?
Absolutely. I mean, absolutely. If you can get the lowest grain of that data into your data lake, as I mentioned, your analytical layer, which you can create on top of your lowest level grain of data, you can absolutely use that to run your own models. You create your own models to see what your customer behavior is.
This is an interesting one. Chris asks, how is data blended in a data lake, and how is it contextualized so that you can make sense out of it, and which tools are available to provide context for different domains like banking and manufacturing and e-commerce?
Absolutely, great question. I think so. Data blending, in a sense, I would say, once you've got your data up to the mirror layer, which is like you're getting your sources ingested into your data lake. Now, the moment you start thinking about, okay, how do I make it more meaningful outcomes from this data? I want to identify insights from this data. You want to contextualize it, right? Now, what you're trying to do is you're trying to find meaning through the data, and then the way you do it is, again, you find your fact entities and your dimensions. You're trying to build a data model on top of your data lake objects and trying to basically combine the data in such a way that you're still not normalizing the data. It's basically in a denorm format, but you can still use it in different analytical tools by combining those different set of objects and saying, I can create the relationship between these objects and I have the lowest transaction into it. Now, the tools that you have can either aggregate the data, can present into a visualization format. For example, you can talk about Tableau, right? Now, I would take, let's say, the purchasing data, my banking data, which is like my payments data, my bank information, and the receiving information. I built a data model of all of those different data streams and put it into my data analytical layer using Tableau or any other visualization tool, or let's say Oracle Business Intelligence Suite. I can then create a dashboard of that data model, and either I can visualize it, or either I can create a tool which can basically present the data in a raw format, which is made available to the consumers. So the blending happens through the data architects, the data engineers. Basically, they work to create that architect model wherein the different disparate data elements can be combined to give a more meaningful and an insightful outcome through the combination of the data. Tools, as I mentioned, you can have different visualization tools which can run on top of it. Data IQ is another one which is there. A lot of people use R and Python as languages to build their own data models and make their own outcomes on top of data lakes. So there is not just one tool which is there, but there's magnitude of tools which can give insights and outcomes to different people.
And what skills and courses should people focus on to become conversant in what they need to know for data lake, using data lakes and incorporating them into their work?
I'm just trying to think through this. So if I understand the question, you're asking like what skills people should have, or how should they think that they can incorporate the data lake into their work environment, right?
Yeah.
I think one piece is thinking differently from the traditional models, because a lot of times we are so focused and so narrow thinking on the tools that are already available or the data warehouses. A lot of organizations have spent time building data lakes but not using them, and I think that's the biggest mindset change. That start building the data lakes with the outcome predefined. What you want to accomplish as an outcome, that should be identified first. The data lake should come second. Unless and until you don't know what you want to accomplish as a result, as an outcome, as an insight. If I want to give a more real-time insights and outcomes to my CEO, I would start thinking about a data lake which will have more real-time data streaming. Whereas if I want to look at a traditional way of thinking about, okay, I want to give 1 quarter back of reporting, a traditional data warehouse still does the job. Data lake would still make sense because you can still think about, okay, how do I get to the next level? So I think understanding what you want to accomplish as an outcome is very critical before you say, okay, I want to create a data lake. Once you've understood what the outcome you want to drive, I think it becomes much easier for anyone to identify what are the elements that should go into a data lake or how the data lake should look like.
Okay. I think we're at our time, and we had a number of other questions that unfortunately we can't get to, but I thank you for handling as many as you did. Very helpful information for everyone. And so if you give me a moment here, I will.
Sure, Stuart.
Okay, and I want to say again, thank you to Chandan for being here. Here is his LinkedIn information if you'd like to reach out to him that way. And you'd like to thank our audience, Chandan.
Absolutely. I really appreciate people for joining in and listening in at this hour. I know for a lot of folks in India, this is a pretty late hour, but I appreciate if you're able to join in and able to listen to me.
And we will be sending a recording link out after this event, probably in the next day or two, so that you'll be able to go back and review the information that Chandan has provided. We also want to thank our partner Freshers World. Freshers World is a major job portal for India, and we are proud to team with them for a number of these webinars. So if you are out there looking for a job, they're a great resource. Another great resource is a program that we've introduced at Simplilearn called Skill Up, which allows you to access a lot of our learning content for free. Over 1,000 hours of the video courses we do in over 300 skill areas. These are not our certification courses, but these are a great way to sample the material. And again, it is all free. So we hope we'll see you at a future webinar. Our next one is next Thursday. Career webinar on the changed landscape of tech hiring. Advice from the CTO of Hacker Earth about how to hire tech people in today's environment and how to get yourself hired as a tech professional. And that will be a great session. And please do reach out to us on our social media channels, Facebook, Twitter, and LinkedIn. We love to continue this conversation with you. And we look forward again to seeing you at future webinars. Thanks again to Chandan and everyone who's here today. And that concludes our webinar.
Thank you, Stuart. Good night and have a good day to the folks.
Thank you.